Okay, welcome back, and now we're going to go through the definition of concave up and concave down. So, definition 1 says, let f be a function that is differentiable over an open interval I. If f prime is increasing over I, then we say it's concave up over I. If f prime is decreasing over I, we say f is concave down over I. Okay, so now that's the definition. The question then becomes, how do we apply this definition, or how do we use this definition to determine the concavity of a function over an interval if we don't have the graph, right? It's one thing to have the graph, but what if you don't have the graph? How do you determine concave? How do you know that f prime is increasing? Well, we can look at the derivative. So we know that a function is increasing, right? If we use corollary 3, remember corollary 3 of the mean value theorem, right? If the derivative is positive, we know that the function is increasing. If the derivative is negative, we know that the derivative or the function is decreasing. But what if the derivative, right? What if f prime is a differentiable function over the interval? Well, then we can apply the corollary to the first derivative, meaning that we know if the derivative is increasing, it's concave up, and we know that if the derivative is decreasing, it's concave down. So how do we know if the derivative is increasing or decreasing? Well, if the derivative function is differentiable, we can apply the corollary to the derivative. So meaning that if we take the second derivative of f prime, if the second derivative is positive, that tells us that the slope is increasing. The derivative is increasing, which means concave up. If the second derivative of the function is negative, then that's going to tell us that the derivative function is decreasing, which means concave down, which is going to lead to our next theorem that we're going to introduce. Have a great day.